Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. Till now in the second part of the course, we have completed the basics of the machine learning systems and we have talked in detail about the natural language processing systems. Now we will start with the core concepts of some of the core concepts of the industrial engineering, that is scheduling and facility layout, and then we will try to accomplish the process of finding the solutions for these systems by utilizing the meta heuristic approaches like genetic algorithm. So today we will start with the foundational concept of the scheduling and then we will later talk about the facility layout problems. So let us start now. Scheduling is a decision making process. Okay. Now these approaches are used regularly in manufacturing and service industries. Now the main task is to allocate resources for task completion. So in these manufacturing or service industries, there are different kinds of operations that needs to be performed, right? Now to perform these operations, we require resources. So how to best allocate these resources for the completion of this task is what is scheduling is. Okay. Now the goal is to optimize the objectives in a particular setting. So let's say in a factory you need to perform all the tasks so that none of the tasks get delayed, right? So that you can deliver your product in time. So there are different kinds of objectives that we will talk about later, and we need to optimize these objectives so that our goal can be achieved and the process of scheduling will be beneficial for us. Now resources in a manufacturing or service industry could be machines in a workshop, or runways at an airport, or processing units in a computing environment. So this is nothing but your CPU. Your CPU handles multiple tasks and the CPU needs to perform all of these tasks in a way so that your goal, that is the objective of the CPU, gets optimized and all tasks gets completed in a particular time frame, right? So even the small unit like CPU has different kinds of schedulers that are developed by different organizations that perform these kinds of scheduling operations at CPU level, right? Also there is a classic example of airport scheduling system where we need to schedule different kinds of airlines, their space where they get located in a particular airport at a particular day and when they need to depart or when they need to arrive, so that the complete operations of the airport stays streamlined without any delays. Now talking about task, each task has some each task has some priority level. So not all tasks are equally important. So let's say it could be earliest starting point or a due date. So let's say if you have 10 or hundreds of tasks, and out of those 100 tasks you have 20 tasks whose due dates are very near, then you need to schedule them early, right, so that they don't get delayed. Now objectives could be minimization of completion task, completion times, or minimization of number of tasks. So we will see these things in detail. Now let us talk about an example of a major airport and why scheduling is required in that airport. Okay, so let's say at a major airport there are dozens of gates where airlines make their airplanes stay. Okay, and hundreds of planes arrive. So gates and planes, they both vary based on their size and requirement, right? So let's say you have a very big plane, an airline bought a very big plane and you need to land it in this major airport. So the gate where it needs to be landed should be such that it can accommodate that plane, right? Now planes arrive and depart according to a schedule. So what does this schedule contains? Schedule contains certain amount of randomness. So this randomness is what is making this problem critical. Why? As an example, for this major airport example, these kind of randomness could appear due to weather issues or delays at other airports from where the airline is coming or going, and at the arrival of a plane. We have three things to do. So these are the different tasks that the airport authorities need to complete when an arrival of a plane happens, right? Passengers gets deplaned, plane may need servicing, departing passenger needs to be boarded. These are three broad things that are completed by at each arrival of a plane at an airport, right? Now, how we can model this airport system is like scheduled departure times can be viewed as due dates. So, this becomes a performance measure. Now, let us say if a boarding gets postponed, so plane remains for extended period of time at the airport. Now, this extended period of time is a kind of a resource that this plane, which should have been departed by now, is utilizing for from this airport. So, if you have created a schedule beforehand for some other airlines to utilize that space which this airplane is utilizing, then you need to reschedule those resources that you have already allocated, right? So, these are the different kinds of problems that this scheduling system needs to understand and model all of these operations beforehand. So, scheduler needs to assign planes to those gates that are available. Rescheduling. So, one of the objective in this major airport scheduling problem could be minimize airplane delays and work for airplane personnel. Now, these airplane personals are also your resources that you need to allocate. So, if you are allocating these resources heavily, you may everything is associated with some kind of cost. So, you are utilizing your cost and you are assigning these personals more than what they should be doing, right? So, you are actually increasing the cost of operating a particular airport due to your airplane delays or some other events like this, right? So, scheduling will impact your all of the cost that is associated with your airport operations. So, here we can understand that gates are the resources and resources are these resources are scarce in nature, okay, and handling or servicing are the task or operations. So, departure represents the completion time of the job. So, if you want to model this complete airport scheduling problem, you can identify objective like this, minimize airplane delays, and your resources like gates, right? Your task as handling these arrived airplanes or departing airplanes and servicing of these airplanes, and your departure represents the completion of the job, right? So this is how you can model a simple airport scheduling problem, and then you can create your constraints and other things to develop and optimize your model, right? Now this is just an example. You have different kinds of examples in manufacturing and servicing industries. As I have already told you that a CPU is also utilizing the scheduling operations, right? Now let us understand the fundamental concepts of scheduling with their key terms. So we will try to focus on a manufacturing industry. So we will try to utilize those things like different kinds of work centers, jobs in a workshop, right? And therefore we will utilize these terminologies for understanding the scheduling operations. So let's say in our manufacturing environment, there is a job. Okay, so job could be a product or order that requires processing. And while modeling, we usually denote a job by J subscript. Okay. Then we will have different machines. So these are nothing but your resources to process jobs. This is denoted by I as a subscript. Okay. The next thing is operations. These are the tasks performed on a machine. And these can be denoted by O of I comma j. Okay. And how do we read this? It is the operations performed so this is denoted by O I comma j, and we can read this representation as operations performed on jth job by ith machine. Okay. The next thing is processing time. So this is the time needed for operations on a job by a machine. This is denoted by P I comma j. Okay, and this is the time taken by ith machine for jth job. Other term is release date. This is the earliest time when a job denoted by J can start getting processed. Next term is due dates. This is denoted by D underscore J, due date for jth job, right? So this is the committed completion date of the job J. Next term is your flow shop. So this is denoted by FM, where M machines are placed in a series. Now each job goes through all machines in the system. And these are some of the conditions that this kind of setting must follow, right? So when we are saying a particular manufacturing workshop as following a flow shop kind of conditions, so there should be M machines that are placed in a series format, and each job goes through all of the machines, that is they get operated by every machine in this shop, right? Now all jobs follow the same route. Each job will join the queue of another machine placed in sequence. Queues work in first in, first out format. FIFO. So let us try to visualize this. So let's say you have 4 machines. Now in a flow shop, all of these machines are placed sequentially. So here comes your input, your job that is still unprocessed and it needs to be processed, right? And here goes your final output. So what happens is this flow shop will make you place all your machines like M1, M2, M3, M4 in series, and when this JS job gets to first machine, it will gets processed at this first machine and then it will gets transferred to M2, then M3 and M4 in a series format. Okay. Now let's say the processing time of M2 is very large. So most of your jobs will try to get accumulated at this position. So this is the queue for M2, right? So that is why we are saying here that each job will join the queue of another machine placed in sequence. So if this is the bottleneck of this whole system, then the queue will increase here, okay? And these queue works like first in first out. So whatever job that arrives first at this queue will gets processed at the earliest, okay? So this is your simple flow shop and it is also known as the assembly line. So, assembly line works in this way. The next term is the flexible flow shop. Flexible flow shop. These are also known as hybrid flow shops or multi processor flow shops. Now, this is the generalization of the flow shop we discussed earlier, right? So, what is changing here? There are C stages in series and n machines are in parallel. Now, each job goes from all stages, right? So, if there are C stages, so let us say from stage 1 to stage 2, like that, but they are all in series, so they have to follow the sequence, and at each stage job J can utilize any of the machine from the machine pool available at cth stage. So, now let us design this flexible flow shop. So, let us say you have this stage 1, then stage 2, then stage 3, right, and you can place multiple machines here. So, this is stage 1, this is stage 2, and this is stage 3, right. From here your input job will arrive at stage 1, then it will go to stage 2 and finally to stage 3, and this will give you an output. So, what we are saying in this flexible flow shop is that each job will have to travel from stage 1 to stage 2 in a sequential manner. It cannot go directly from stage 1 to stage 3, but now unlike simple flow shop, you have multiple machines that this particular job can utilize in a particular stage. So, it can reduce your bottlenecks, right. So, this is how flexible flow shop works. The next concept is job shop. So, in this setting M machines are available and each job has its own predetermined route to follow. Okay. So, there is a concept of recirculation. This is A job can visit the same machine more than once. Okay. The next concept is flexible job shop. So, this is again the generalization of job shop. Okay. And how we are generalizing this? Allows parallel machining environments. Okay. So, there are C work centers available, and each work center contains identical machines. But the most distinctive feature of job shop with your flow shop is each job has its own route. So, a particular job does not have to follow particular sequence of machines to get their operations done, right? Okay, so let us stop today at this point and we will try to continue understanding more key terms in scheduling in the next lecture. Thank you.